Hi, this is Laxman Lonkar from Government Polytechnic Washim, lecturing in electronics department. So these are the examples of open loop control system. So there are different types of different examples over here. So we'll take one by one. So first one is a traffic light control system. Everyone knows about this. This traffic light control system, how it will work? It is a one-way control system. Like if you are applying just time, whatever the time was set in this control system, in this traffic light control system, so it will work accordingly. Suppose there are three different color like red, yellow, and green. So you can set the limit time limit of this color. So for 30 seconds, 60 seconds, 40 seconds accordingly. So suppose if there is a large traffic on the road, then you can increase the time limit. So suppose we'll take for let's take an example. We'll set the time period of 30 seconds for red, 30 seconds for green, and 37 for yellow, and accordingly. So it is a one way kind of system. Like if you're setting the time, just it will glow for suppose we're taking you can set the time of 30 seconds for red light, so it will just glow for 30 seconds. Once 30 seconds is over, it will just change the color, and it will off, and then our green color will on, or green light will on. So no, it is no matter how much traffic on the road, whether this traffic is there is no one, or whether the traffic is high traffic on this road. So it doesn't matter how much traffic on the road. So it is just work accordingly, or it is just work on time basis. So again, we can take an example of washing machine. So dirty clothes your input, and you want clean clothes. So if you set time, then if you're in washing machine, when you put your dirty clothes, then you can set time. So in washing machine, dirty clothes you can put in your washing machine, and you can set a time like 3 minutes, 4 minutes, 5 minutes accordingly, or according to our knowledge. Then it will just wash our clothes, and no matter whether that clothes are clean or not. Then after time, suppose you will set 5 minutes. After 5 minutes, it will just off, and again we need to look back whether the dirty clothes are clean or not. Then if it is not clean, then again we need to set some more time, 2 minutes or 3 minutes accordingly. So this washing machine is again open loop system, means it will not bother about whether that clothes are clean or not. So again we need to manually we need to see, and we need to again do the process. So this is again domestic water heater, like we always use water heater. So in water heater, again we need to see whether that water is hot or not. So this is again type of open loop control system. See there is a hand dryer. Again, this is a very good example of open loop control systems. Like what is the electric hand dryer will do? It will just when you put your hand under this electric hand dryer, it will just come out some hot water from this electric hand dryer, and your wet hands are the input for this hand dryer, and it will just throw the hot water. Then your hands will dry. So but no matter how long you need to dry for, or how long it will work, just at what time if you are pushing your hands for 3 or 4 minutes, then it will just on. If you get back your handbags, then it will off. So no matter whether your hands are wet or dry. So again, we can take an example of bread toaster. So bread toaster, again same. If you slice of bread, if you put a slice of bread in the bread toaster, so no matter whether it is light brown color. So light brown color is your output. That means the bread color may be dark black, dark brown, maybe very dark. So this is no matter how long it will take for the means what is the output. It is no matter of the output. So this bread toaster is again a very good example of open loop control system. And this is TV remote control. You all are familiar with the TV remote control system. Like if you put 5, if you click 5, then it will just change the channel from previous to 5 number. If you click up and down, just it will do accordingly. But it is doesn't matter whether what you want, right? So which you want, so you can change from. You have to apply your input, right? Manually you have to apply input. So this is again a very good example of open loop control system. So these are some examples of control system. Now we will see what are the advantages and disadvantages of open loop control systems. Actually, I already told you, like there are only two components. One is controller, and in this block diagram, see, this is a block diagram. There are two components. One is controller, and second one is plant or process. Only there are two controllers, two elements in this block diagram. So due to this less number of component, right? Due to this less number of component, there are so many advantages. So if you keep in mind these advantages, like if you study this advantages and disadvantages, then you will be able to compare open loop and closed loop control systems. Means that will be very easy for you. So first advantage is they are cheaper, means as less number of components to build, means there are only two components, one is controller and second one is process. So it is very cheaper, means less cost, we can say. Also there are the second advantage is like the maintenance is easy. Why maintenance is easy? Because less number of component again, and again it consume less power. Why? Because there are only less number of components. This is the reason to consume less power. So they are convenient to use, right? Convenient to use means just third advantage is they are convenient to use. They are convenient to use means actually this is a one-way control system. Like it is no matter what about the output and like just it will just plug and play kind of control system. Means if you can take an example of your electric bulb in our house. So if you put if you push on switch, then it will just on, no matter whether it is there are person or there is need of light or not. When you go out, then you should have to manually off the button, right? So this is again there is no matter whether there are some person in the home or not. So this is the open loop control systems, and therefore this is convenient for convenient to use. Like you need to just push button on and you need to push off button. So this is very convenient to use, and this is very simple and easy to build, right? Very simple. Why it is very simple and easy to build? Because again there are very less number of components. Means you just need to have one controller, and what is the plant or what is the process you need to fulfill. Just you need to connect to controller to the process, then it will just work. And this is a very good advantage of this open loop control system. They are stable. Actually, I already explained you what is mean by stability. So this is very stable open loop control system than closed loop system. So there are some disadvantages of open loop control systems. So disadvantage is low bandwidth, right? Means the range of frequency is very low over the output response. And second disadvantage is they are less accurate. So accuracy, obviously there is no feedback systems. There is there is no path of feedback, like output is again given to the input and input will compare. There is no kind of that kind of system. So there is a disadvantage of this open loop controls. So there is accuracy will be less and it has slow response, obviously, because it is again there is no feedback, and it doesn't know how output will produce it. Whatever the input is we are applying, it will just produce the output accordingly. So last one is it cannot correct the output deviation automatically. So already explained, like suppose some kind of disturbances added in the control systems in the controller at the time of applying a reference input or at the time of producing the controller output to the process. If output is altered, then there is no automation. There is no automation to correct that output to back to the previous one. So this is very I would say this is important disadvantage of this open loop control systems. it is very drawback, and due to this only we will move towards the closed loop control systems. So this is a block diagram of control loop systems. Actually, there are again this is schematic one. So this is the block diagram of control systems. So we'll see, like you can see where this is you are applying input to this error detector, and there are three components: controller, plant, and feedback element. See, there in open loop control system, if you see the block diagram of control system, there is only controller and process or plant, right? So there is no feedback element which will give the part of output to the input, right? So but in closed loop control system there is a feedback. See here, there is feedback. It will just taken some part of output and it is given to the input. So due to this element only, the closed loop system is we can say the accuracy is good than open loop control systems. In closed loop control system, we will see here, we input from the input side, we are applying input to the controller. Again, that controller is producing the output and giving to the actuating signal or to the actuators, and actuators given to the plant or process, and then it will produce the output. But what is the output is producing these systems? It will just give it will take an output. Again, this will sense the output, and it will feedback element means the sensing the output. It will sense the output and it is given to the input. So this input in the error detector will what will do? It will just produce the error signal. What is the output producing these systems, and what is the required? What is the desired input, right? So your reference, what is the reference input and what is the output this system will produce. So it will depending upon this input and output, it will take a decision. It will produce an error signal. So this feedback can be of positive feedback, that is here is a plus sign, and can be of negative feedback, here is a minus sign. So we'll see in detail what when you plus sign means what and negative sign means what. So depending upon the positive feedback and negative feedback, it will produce this error. This is error detector, right? This is summing point. We will call it as a summing point, and it will produce a signal accordingly. So the error signal will goes to the controller, and controller will take the decision whether the output, what is the output is producing. So whether we need to increase the output or we need to decrease the output. What kind of decision we should have to take. So the controller will take the decision, and again depending upon the error signal, it will produce the output. And again it will giving the command to plant, and plant will try to get the output again back to its position, or what is the desired output this system have to produce. So this is all over the block diagram. You can see this is again this is important for our derivation purpose. So this is also important. See, R of S is keep in mind this R of S, B of S, E of S, G of S, because when we will see the block regression techniques or transfer function, this is required for that purpose. So the R of S is the input signal you are applying to this error detector, and whatever the error is producing, that it is nothing but the difference of, it is a difference signal actually, plus minus signal. So whatever the signal the error detector will produce, that signal is a E of S. So E of S is the combination of R of S and B of S, right? So E of is the output, and that a combination of R of S and B of S. So again E of S is the error signal we are given to the G of S, and G of S will produce the output, and again the output is C of S, and C of S again given to the this is H of S is the feedback element, and this feedback is again going to the error detector. So this is all about the closed loop control system. Thank you.